Okay, we're starting here with section 4.4, and we're looking at factoring polynomials using what we call the GCF, or the greatest common factor. Now, if you remember the distributive property, okay, I want to go through this here real quick. Distributive property, if we had 5 times the quantity x plus 3, we would multiply the 5 times everything, and we would get 5x, and plus 5 times 3 is 15. Okay, now, essentially, I want you to think of this when we do GCF. We're doing the distributive property backwards. So if we multiplied 5 in this case times everything, and I take this and I want to go backwards now, okay? So if I want to go backwards, the opposite of multiplication is division. So what I want to figure out is what's the biggest number that goes into 5 and 15 in this case? Well, that's going to be a 5, and what I'm going to do is I'm going to put a parentheses, okay, just like before. So now up here when we distributed, we multiplied everything. Well, now when we want to factor, we want to divide. We want to do the opposite of it. We're going the other way now. So what I'm going to do here is I'm going to take 5 divided by 5, and I'm going to get 1, or in this case, as I look at this, that's a 1. And then what I'm going to do here is I'm going to take x divided by nothing, or in other words, you're going to hear me say take the exponents and subtract them. Well, if I have one exponent here, I have one x here, I don't have any x's here, then the x stays inside. Okay, and then I'm going to look at taking 15, dividing it by 5, and it's going to give me positive 3. And I end up with the same thing that I began with. Okay, so essentially, factoring is the distributive property backwards. So, a couple things here that we want to look at. First of all, we want to find the greatest common factor of all of our terms. The question we're looking at here is, what is the biggest number that will go into all the terms together? Okay, and then do all the terms have the same variable? Which I'm going to talk about here when we go through some of these examples. Now, using the GCF, you're going to divide all of the numbers, and then you're going to subtract the exponents to figure out what's left over inside the parentheses. You're going to subtract the exponents of the variables. Okay, so let's take a look at this first example, number 1, 6n squared plus 9n. Now, as you're looking at the numbers, what you're trying to figure out, what's the biggest number that goes into 6 and 9? Well, that happens to be the number 3. So I'm going to take a 3, and we're going to pull that out front. Now, the other thing that you notice is that both of these terms have n's. Okay, this is a binomial, remember, because it has 2 terms. So, since both terms have the same thing, I'm going to take an n out, and it's going to be to the first power, or it's going to be to the lowest power of exponents. So notice here, this guy has a 2, there's no exponent here. Well, that's actually a 1. I always take the lowest number of exponents away. Okay? Alright, so then what I do here is, again, instead of multiplying like you would with the distributive property, I'm going to divide when we factor. So 6 divided by 3 is going to be 2. Now, the way I think of it is, I have 2 n's right here. I'm taking 1 n away. How many n's will I have left over? Well, I'm only going to have 1 left. Okay, so essentially what I did here is I took 2 minus 1 to get 1 left. Or 2 n's, I took 1 away, there's still 1 left. So now I'm going to take 9 divided by 3, and I'm going to get 3. And then what I'm going to do now is I'm going to look at my exponents. I have 1 n here. I'm taking that n away, so it doesn't have the n anymore. Okay, and then this is just factoring, and I'm complete. Okay, so find the biggest number that goes into both numbers. If they both have the same letter, we take out that same letter, the lowest exponent, out. Okay, now this example here doesn't have both variables in it. We just have a 7n squared minus 21. So first question I'm asking myself is, what's the biggest number that goes into 7 and 21? Even if that is negative, that's fine, that doesn't matter. So what I'm going to do is I'm going to take out a 7, because 7 is the biggest number. Now, Do they both have n's? No, they don't. So I can't take and put an n out here because they don't both have it. So 7 divided by 7 is 1. I have two n's right here. I'm not taking any n's away, so I still have two n's on the inside. I'm going to take negative 21, and then I'm going to divide it by 7, and it's going to give me a negative 3. And now you have factored that binomial. You took out a greatest common factor of 7. They both had a 7 in common with them. Okay, two more examples I want to look at here on this set. And this example here, example number 3. So I'm looking for what is the biggest number that goes into 25 and 20. That happens to be a 5. They both have x's. The lowest number of x's is to the first power, so I'm going to at least take out one x from everything. So 25 divided by 5 is 5. I have two x's here. I'm taking one away, so I still have one left over. Then we've got negative 20 divided by positive 5, which is negative 4. And I had one x here. They took it away from me, so I don't have it anymore. And that's it. You're done. There's nothing else to factor. That is simplified. Okay, now on this fourth example, you'll notice the one thing that's different on this one is there's no number in front of x squared. Well, there is actually a number there, but we don't actually ever write it. There's a 1 there. Now, what's the biggest number that goes into 1 and 2? Well, it's just 1. So the difference between this one is wait, do these guys both have x's? They sure do. They at least have an x. So what I'm just going to take out an x this time. Okay, well, 1 divided by 1 is 1. I have two x's here. I took one of them away. If I took one of them away, how many are left? Well, there's just one left. Negative 2 divided by 1 gives me negative 2. And then I had one x here. I took one of them away, so I don't have it anymore. I can close out this parentheses. Okay, so now using those examples, you should be able to complete the first page of the class cake with factoring binomials with the greatest common factor.